On the table here I have a failed DT Swiss hub on a bicycle wheel, and all the components from the hub have been removed and are here. I have absolutely everything here: axle, bearings, end caps, spacers, washers, everything that came out from either the hub or the Freehub. In this video for your hub or Freehub rebuild, I will show you and explain how all of these components geometrically fit together inside either the Freehub or the hub. As much as I can, in the span of this half-hour video, I will also show you and explain how these components work together, how they interlock or couple together to produce forward rotation in one direction and independent counter rotation on the Freehub's part in the opposite direction. As I go along, I will share with you critical sizes of these components and some replacement part options. All the critical sizes quoted are either nominal or taken with a vernier caliper with a 1 decimal digit accuracy. No micrometer has been used, no fancy measuring equipment, just a simple vernier caliper. Let's get started with the actual make and model of the hub and what went wrong with it. Throughout the video I'm gonna have to use extreme close-up and long shot and toggle between the two. That's gonna take a little bit of time, sorry about that. The hub's make and model is printed on the hub itself. It says DT Swiss Hügi hub, model number is 240. There. What went wrong with it, sorry I can't get closer to the lens. What went wrong with it is fairly obvious. Here the flange broke. Why it broke, very simply, is quite possibly because this ring was over tightened. It gets over tightened as the wheel is rolling forward. That's the direction of the pull on it. Whether it's a design flaw or was over tightened by an overzealous mechanic or homeowner, I don't know. If I remove this ring, this is the first component of the hub. This was really difficult to remove. It was so tight in this space. I can get you a close-up of this hub. This is an aluminum hub, or aluminium in some markets. And some surfaces are, this is a cast hub. Some surfaces are machined into it. Notably, it's an important feature. There is a shoulder here at the hub's flange. This seal is going to go into this shoulder. It's really important. Seal. I'm going to explain how this works with the Freehub. This is the Freehub and this is the drive side of the hub. So that's how it looks like somewhat when they are assembled together. So this shoulder here is where that seal needs to be located. Then you have a threaded part on the hub, and a machined surface on the inside of the hub provides for a space to press fit a cartridge bearing here into the hub. On the drive side here, a smaller, you can see we have 4 bearings here. The smallest bearing, or the smaller bearing, 2 sizes. Those ones are identical and not one smaller. We'll get you the sizes. So the smaller one fits here on the drive side and is press fit in there. And on the other side, a larger bearing needs to be press fit in place. I want to point out, just for working with this hub or identifying this hub, that it's straight laced on the non-drive side on this wheel, and it is 6/over laced on the drive side here. And this wheel has a Mavic rim. This make and model came off of some bicycle, somebody gave it to me. So just before I explain the geometric oddity of this axle, I want to point out that if you choose to press fit the 2 bearings into the hub, that's not gonna let you install the axle. Let me explain why. So smaller bearing on the drive side. If you have both of them in the hub, the axle which features two flanges on it there. If these two bearings are press fit into the hub, you can only push the axle about this far into the first bearing and is not going to go through the second bearing. I hope this makes sense, because the flange is going to be in the way, or one of the bearings is going to be in the way. So how you can install the hub and the bearings is press fit one, possibly the smaller one, on the drive side first. Then you can fit the axle through the hub, and like so, and then press fit the second bearing with the axle sticking out from the hub. That's how this can be installed tight against this flange. I hope that makes sense. That's the only way really to make it work. So smaller one gets press fit on the drive side, axle goes through, looking visually something like this, and this is how this bearing needs to be installed with the axle in place, like so. So whatever you use to press fit this bearing in place with, it has to have a 15mm diameter hole in the middle for the axle. So let's talk about sizes of things, axles and bearings, and this ring that possibly caused the hub flange to break off. This ring is 33.9mm in diameter on the outside as measured. The 33.9mm size takes of course into account thread truncation. The tops of the threads are not sharp, standard metric thread. Everything is in millimeters, metric sizes. So nominally probably this is 34mm in diameter. If it as a part listed, probably like so. This is 8mm wide or thick, and the thread pitch on it, let me get you a nice close-up on this, is 1mm. Okay, so it's a metric coarse thread pitch. The inside diameter is really difficult to measure with the spurs of the caliper, but I estimate 26mm for inside diameter. So that's between the splines. These are not really gear teeth, these are splines, and there are 26 of them. I started counting at this one at the 12 o'clock position, 26 splines for this. Likewise, the Ratchet will also have 26 splines, and the inside of the Freehub body also has 26 splines, so they work together. More about the ratcheting later. Let's look at the axle. Nominally is probably 150mm long. I measured 114.8mm for length. Like I said, it has these two flanges on it, but on this part and on this part it's machined down to 15mm nominally. The bearings, therefore, and I'm just gonna stack these on the end for show and tell, for size comparison. The bearings also have a 15mm inner diameter nominally. So the axle and the bearing cannot be both 15mm exactly. One of them has to be smaller. The axle is probably slightly a few hundredths of a millimeter smaller than 15, if the bearings are exactly manufactured at 15.0. So the bearings inside diameter is 15, I hope that makes sense, millimeters, and all of the bearings are 7mm wide. The skinny guy is 24mm in diameter outside, and the other three are 28mm in diameter. The axle otherwise is hollow and made of aluminum. The bearings are shielded on both sides. I removed one of the shields the bearings that this hub came with has for cage material, plastic cage in it. Replacement options include picking bearings that have metal cages, sorry, just one metal cage, but you get the idea. Instead of the plastic, metal cage has lower rolling resistance as the bearing rotates, so less friction as a result of a metal cage design. Good manufacturers include SKF, NSK, FAG, NTN. Let's talk about seals a little bit. I dented the seal there, but it's not a big deal because in bearing removal they are not going to get reinstalled or re-greased. These bearings are at least 10 years old. The whole hub design is about 15 years old. Maybe DT Swiss had multiple failures like this due to the over tightening of this threaded spline ring. It gets tighter in normal operation as torque is applied to the drivetrain, so maybe it kept breaking for many users. I really don't know, separate video. So the bearing designation is printed on the bearing's inner ring. This is really difficult to film, and I'm experimenting with the light a little bit. The bearing's designation is at the 3 o'clock position, maybe even closer. So the bearing's designation is, it says Swiss made on it here at the 8 o'clock position or so. I don't know if you can read this bearing designation number that's printed in it, but it says thereabouts at the 8 o'clock position. Light is good. There you have the digits. The digits are 61902. For replacement bearings, the digit 1 for some manufacturers is optional, such as SKF. So this is listed typically as 6902 bearing. And again, its dimensions is 15, 7 and 28. Different seals are available, non-contact and contact seals, besides having different cage material on some of these bearings. And non-contact seal means that it's not watertight. If you have creek fording in mind, probably the non-contact seal bearing is a bad choice, unless it's for one race. The contact bearings have higher friction because the edges of the seals are actually tight against either the cage or the bearing balls or the edges, the rotating edges of the inner race. So the non-contact seals generate less friction. The contact seals result in more friction, but they are watertight. Not watertight to the degree that they can withstand creek fording for hours on end or day in, day out, but in normal rainy operation they should work a lot better than the non-contact seals. So that's bearing options, and that's the axle sizes. The last bit that I want to show you for sizes is these two spline rings that produce the ratcheting action. I'll show you how all of these work together, but this is basically how ratcheting is produced between these two toothed surfaces there. For this ratcheting to occur, one of these are spring-loaded and need to move vertically up the amount of the height of the teeth on the side. These are hardened steel, really sensitive to corrosion. So that's why the seal that's on the Freehub here is gonna be critical, because these live right underneath there in close proximity. So full immersion of the wheel all the way up to the hub, not really recommended. Or these need to be lubricated, greased really generously should a creek fording occur in your line of cycling duties. So the outside diameter of these ratcheting spline rings is 27.7 millimeters, inside diameter 19 millimeters, and they have a combined thickness as is 11.2 millimeters. And like I said, there are 26 splines cut into it. These are not really gear teeth, because gear teeth work this way, but these don't. So that's that component. Now, how do these all fit together? Let's go over it. Like I said, the hub is fairly straightforward. The smaller bearing gets pressed fit on the drive side. On the axle, this is going to be the drive side where the Freehub is going to be located. So press fit one bearing into the hub, put the axle through it, and install the second bearing, and that's your hub. The second bearing on one side gets an end cap. This end cap has a rubber seal about it, and this rubber seal can be removed from the end cap and is asymmetrical in design, wider on one side and thinner on the other side. It should be nice and pliable, soft like this. Although this is 10 years old, really good quality, at least 10 years old. So this wider half is gonna go against the flange on the end cap, like so, and just slide it in place. At this point there should be about a 1 millimeter gap between the side of the bearing and the side of the rubber seal here, and it gets pressed in place with a snap. There, that's all there is to it, and this fit compresses this seal slightly. Removal doesn't take a whole lot of force either, that's all it takes. So again, snap it together, and force of removal, this one, so a little bit of twisting and they come apart. So this is how the hub is assembled, ready for, in this case, this end cap is configured for a quick release skewer to go through it, and the cam action on it is clamping the whole assembly together with the Freehub on it. Let's talk about how the Freehub fits. There are two spacers here, one longer, one shorter. You can kind of see how the story is going to unfold at this end of the axle. So here's a bearing, spacer, bearing, spacer, bearing, end cap, just roughly. There are more components, I'm going to show you all of them. So roughly, there's going to be a spacer, and all the components from here on need to be placed inside the Freehub. I'm going to show you how they look like on the axle here. So inside the Freehub there's going to be a bearing, the shorter spacer, which is 11.4 millimeters long, the longer spacer is 15.4 millimeters long. This is where this bearing goes, and there is an end cap with a washer. There are two more components, another washer and another lock ring that goes inside the Freehub and is part of this sandwich that's inside the Freehub. Let me show you the fit of this end cap here, how it works with this washer. This washer is about 1.5 millimeters in thickness, and you can see from the dirt line, this is how it works with the end cap. It needs to be centered like so. On the end cap there is another shoulder machined into it there. This is how the washer and the end cap work together, like so. And the washer in this assembled position needs to be slightly thicker, or gets to be slightly thicker than the shoulder of the end cap here. This end cap is also press fit on the end of the axle once the free hub is assembled, and gets press fit in place with a snap looking like this, like so. And let's see, the washer got centered, so this is how it looks like when it's in place. This is the full assembly with no looseness, nothing's rattling. Now let me just show you how this assembly with these two extra components fit inside the free hub. There. So these are the free hub bits. I'm gonna put this back on the axle here temporarily, so they are together. So inside the free hub, which is just a hollow tube looking like this with 9 splines on it for the cassette, you can see this 26 splines for the ratcheting mechanism at this end, and at this end there is a thread cut into it. This is where the lock ring locks in place the cassette, and this seal goes here. It's gonna be important later. We're gonna put it down there for now. So the first component then goes into this free hub is this flat washer, which has a thickness of 0.5 millimeter. It's just flat and featureless. This is also a backing for a spring, this coil spring that's going to be installed there for the ratcheting mechanism. So this needs to be sound and properly in place. It's a little fiddly. I'm going to hold it in place with my finger now, and it fits against the spline teeth on the free hub. Next component to install is one of the bearings. Press fit in place, goes all the way down there. The next component against this bearing, which is press fit all the way down there, is maybe not this one, maybe this one, so you can put your snap ring pliers in there. The snap ring needs to be fitted inside the free hub body to about this depth here inside with appropriate snap ring pliers. So this is the sandwich here, the skinny washer, one of the bearings, and this snap ring holding the bearing by the outer ring on the bearing, the outer raceway. Okay, so I hope this sandwich here makes sense. Then this gets slipped in place, and the spacer is sized so that it lies against the inner race of this bearing there, and then you can push the axle through, and then the second bearing gets press fit in place like so, and when the axle is pushed through everything, then the end cap and this washer finish or complete the assembly. So I hope that this sandwich makes sense, how it's all inside the free hub body, and the free hub then gets slid on the end of the axle here. The snap ring needs to be located, like I said, inside the free hub body, and there's a groove inside the free hub body down there. My nail is catching on it, so you have to muscle that snap ring somehow into that groove there. This is about as sharp as it's ever gonna get with the amount of light I have, so you can see that groove there, but as soon as I put my finger in, the light changes, but that's the groove for the snap ring. Last item, the ratchet. So for this I'm gonna have to put this flat washer back in place there, because this is gonna be backing for my spring. Now I can hold it with my finger, but it's not gonna work out too well. I'm gonna just borrow this end of the axle actually with a small bearing. So instead of pressing that washer with my finger, I'm just gonna hold pressure on it with that bearing. Okay, so just this is the splined area where the spring gets installed inside the Freehub, like so. And then these two splined rings, well, one of them gets to be pressed inside the Freehub like so, and the other one gets placed inside this threaded spline ring. They go together fairly straightforward. They go together like so, there, with some room to spare in this threaded spline ring. So how ratcheting occurs is something like this. So this ring is inside this threaded ring inside the hub, and ratcheting occurs there like so. I hope this makes sense. And they rotate forward together, that direction being forward. So you're pedaling forward this way and freewheeling in this direction. Okay, so that's how the skinny washer, the spring, and these two ratcheting rings interlock and interact with each other, producing rotation forward and freewheeling in the opposite direction. Now, last item is this seal. So this seal is really important to keep the moisture out from the steel components. Hardened steel, aluminum unaffected, aluminum spacer, really important. Steel, aluminum washer on the outside next to the end cap, aluminum spacer. So steel spring, steel snap ring, steel bearings there. All of these bearings are affected by moisture, and the aluminum axle is not. So if any moisture corrodes the edges of the inner raceway there and compromises the seal, if you want a seal that has a tight fit and is waterproof, so it's a contact type seal, as soon as flakes of rust compromise the seal's ability to be watertight or waterproof to some degree, then that's not going to happen. So moisture is the enemy here, and that's why this seal is really important. It just simply lies flat with its rubbery side facing the Freehub like so, and this groove or the metal backing on the seal gets placed into this groove in the flange. When the Freehub and the hub rotate together, the seal is not rotating independently either. They all rotate at the same pace together, but when the Freehub is spinning backwards, then the seal is rotating in the groove of the flange here, so it needs to be really well lubricated to keep moisture out from here where the ratchet, the hardened steel ratchet mechanism is, with the steel springs, steel bearings, everything here. Okay, so that's how they all work together. It's been a long video. Thank you very much for watching. Have a happy rebuild.